Welcome back. We are doing paper 9709, variant 13, May, June 2025. So let's continue with question number 2. Question 2 says the first two terms of a geometric progression are 4 sine square theta, 8 sine cube theta. So that means this is A1 and A2, or you may call it U1 and U2. Okay, the first two terms. So side by side, I'm writing also. A1 is 4 sine square theta and A2 is 8 sine cube theta. Now, where theta is an angle such that theta is greater than 0 and less than pi over 6. So that means theta is between pi by 6 and 0 radians, or if you want to understand in degrees format also, so you can write it as this form, but you are not going to give answers in the degree form because your range is already given in the radians. So you have to proceed with that. Only to understand, you can write this, or you can change it into degree form. Okay, so your angle must be between 0 to pi by 6 in radians, given that sum to infinity of the progression is 1 over 2. So sum to infinity is equals to 1 over 2. Find the value of theta. Okay, and theta is that what we need to find. The one more thing that they have given you is give your answer in the form of sine inverse of k. Means don't solve it for the angle, just keep it in inverse form. So starting off with, this is a geometric progression. Okay, so the most important thing is that this is a geometric progression. So solve for it. Finding, if it is a geometric progression, we have to find the common ratio. So R comes out to be the ratio of any two consecutive terms. So we can do, for common ratio, we can do R equals to second term over first term. So 8 sine cube theta over 4 sine square theta. That gives you 2 sine theta. Now this is your common ratio. Now let's write down your sum to infinity formula. What is sum to infinity? Sum to infinity is A over 1 minus R. So A, we know A is same as the first term, A1. So that is 4 sine square theta. And 1 minus R is 1 minus 2 sine theta. Now, we know sum to infinity is equals to 1 over 2. So in place of sum to infinity, we can write 1 over 2. We will just now simplify this. Cross multiply, you will get 1 minus 2 sine theta equals 8 sine square theta. Now rearrange it. 8 sine square theta plus 2 sine theta. I am shifting this 2 sine theta and 1 on the other side. So this becomes plus 2 sine theta minus 1 equals 0. This becomes now quadratic equation. Quadratic in sine theta. If this is the, what do we call it? This is called disguised quadratic. Yeah, disguised quadratic means it is quadratic, but it's not in the same form. So you can either solve it by putting sine theta equals to A. So it becomes 8A square plus 2A minus 1. Now it seems very familiar to students to solve this, or you can directly solve in the form of sine theta. So what I'm doing is, I'm sure you know how to solve this quadratic equation. So I am showing you how to solve sine theta format. Okay. So breaking the middle term, 8 sine square theta plus 2 sine theta minus 1 equals 0. Breaking this middle term, we need two numbers that multiply should give you minus 8, and on adding or subtracting should give you 2. So that is 4 and 2. 4 2 times is 8. Okay, so 4 and 2 and minus 2, because upon multiplication you should get minus 8. That is the product of the outer two terms. I'm sure you know how to do this breaking of middle term. So what do? We should be getting, final answer should be the product of, like, when you multiply the two factors, the numbers you are getting, you should be getting minus, like this product of the first and last term, that is minus 8 sine square theta in this case. And upon addition, you should be getting positive 2 sine theta. So that tells us that it should be 4 sine theta minus 2 sine theta. That on multiplication will give you a minus 8 sine square theta, and on adding or subtracting, it will give you positive 2 sine theta. So this is your breaking of middle term. Minus 1 equals 0. Okay, now take common, 4 sine theta, 2 sine theta plus 1, minus 1 common, 2 sine theta plus 1 equals 0. So 4 sine theta minus 1 times 2 sine theta plus 1 equals 0. That gives you sine theta equals to either positive 1 over 4, or sine theta equals to minus 1 over 2. Okay, so the thing is, they said you are going to give the theta in terms of sine inverse. So if we do sine inverse of 1 over 4, and for the second side, we are doing theta equals to sine inverse of minus 1 over 2. So sine inverse of 1 over 2, you know, is pi over 6. So that gives you minus pi over 6, and that also, if you do in terms of like alpha equals to sine inverse of 1 over 2. Sine inverse of 1 over 2 is pi over 6, but that must be in the negative. So also you don't have the range in other than just from 0 to pi by 6. But this is minus pi by 6, so it doesn't come in the required range. So this will be rejected. So we are going to reject this angle. Not possible or rejected. This sine inverse of 1 over 4 gives you, as I told you earlier, that the range is given in radians, so you are supposed to give answer in radians if they asked you to solve it. But they said give you an answer in the form of sine inverse of k, where k is a rational number. Rational number, that means it should be in some fractional form, in p over q form. So yeah, this is your required result. So I tried to explain everything in this question. I hope you understand this. So this might have helps you. That's all about question number 2. Thank you.